Hello viewers, welcome to add-on. In this question, we are asked to draw and explain the circuit which is required to produce the output given in the figure B when the input waveform is this. So this is our input waveform and this is our output waveform. So from this input waveform, we are asked to produce this output waveform. Okay, so we have to use a particular circuit to produce this output waveform from this input waveform. So the circuit that we are going to use here is clamper circuit, because as we can see in this particular diagram, this is a sinusoidal waveform. We are just shifting this sinusoidal waveform in the negative y direction. Okay. So the sinusoidal waveform becomes like this. This comes below the zero level or the reference level. Okay. So I am just shifting the DC level of the input AC waveform. So this can be easily done. The shifting of the DC level can be done using clamper circuit. Okay. And one thing that needs to be noted, I am shifting in the negative y direction. So we are going to use negative clamper. Okay. So we are going to use negative clamper. So at first, let us draw the circuit of negative clamper. So this is the input AC power supply, which will generate us this sinusoidal waveform. Okay. Then we will connect a capacitor here. Then here we will connect a diode. And across this diode, we will connect a load resistance. And across this load resistance, we will take the output. So what happens in this circuit is that this AC signal waveform will generate this sinusoidal waveform like this. Okay. It will generate this sinusoidal waveform. And this is a capacitor. I am assuming the capacitor has a value of C. And this is the diode, which I am denoting by D. And this is the load resistance. So what happens is that during this AC power supply, during the positive half cycle, okay, the P terminal of the diode, this is the P terminal, right? And this is the N terminal. The P terminal is connected to the positive end of the battery and the N terminal is connected to the negative end of the battery. So the diode will be forward biased. As a result, current will flow within this loop. And as the current flows within this loop, this capacitor will get charged up to the peak value of this input AC power supply. So I am assuming this AC power supply has a peak value of Vm. So this capacitor will get charged up to a peak value of Vm volts. Okay. And as the current gets shorted within this particular loop, we won't get any current flowing through this load resistance. And if we measure the output voltage across this load resistance, it will equal to 0. Okay. So this is the working condition of the positive half cycle. And during the negative half cycle, so I am drawing the negative half cycle scenario. So during the negative half cycle, this negative terminal will be connected to the P terminal and this positive terminal will be connected to the N terminal. So what happens is that when the P terminal is connected to the negative terminal of the battery and the N terminal is connected to the positive terminal of the battery, this diode will become reverse biased. And as the diode becomes reverse biased, no current will flow within the diode. So the diode will act like an open circuit. So instead of writing the diode here or drawing the diode here, I am just drawing an open circuit, because during the negative half cycle, the diode will become reverse biased and no current will flow through it. And this is the load resistance. This is the output V out. Okay. So in this scenario also, during the negative half cycle, as we can see, this waveform has a peak value of minus of Vm. So here also the peak value is Vm. And previously this capacitor was stored with a charge of Vm volt. So the capacitor is already stored with a charge of Vm. And what happens during negative half cycle is that this capacitor will discharge itself onto the load resistance. This Vm volt will get discharged onto this load resistance, and this voltage Vm that we are getting across this input AC power supply, this voltage across this point, we will be also getting this voltage across this point. Okay, as the current flows like this, right? So this voltage Vm, we will be getting this particular voltage across this load resistance, and the voltage which was previously stored in the capacitor will also discharge itself onto the load resistance. So now in the load resistance, the total voltage that we will be getting is Vm plus Vm, which is equals to 2 of Vm volts. And now, as this output, this output we are getting in the negative half cycle, right? So as the output is obtained in the negative half cycle, the clamping will be done in the negative direction. So if we assume the input AC waveform is like this is the peak value of the positive half cycle Vm, and this is the peak value of the negative half cycle minus of Vm. So now when the input is clamped up, okay, so when the input is clamped up, here this is the zero level or the reference level of the input AC waveform. And now in the output AC waveform, the zero reference level is this. But the zero level of the input waveform gets clamped in the negative direction. So the waveform get clamped in the negative direction. So this zero level will get moved from this particular point up to this particular point. So this is the zero level now. So the waveform becomes like this. Okay. So below this zero level, this was Vm. So this will be equal to Vm. And above this zero level, this was also Vm. So this will also be equal to Vm. And if we add this two, we will get the total peak amplitude. This is equals to minus of twice of Vm. Okay. So as we can see, if we use the negative clamper circuit, we can easily do the clamping in the negative direction. So as a result, the input AC waveform, which had a positive peak at Vm and a negative peak at Vm also, gets shifted in the negative direction like this. So here in this scenario, this is the zero reference level of the output waveform, but the zero reference level of the input waveform get clamped in the negative direction. So it will be now like this. So if we draw the sinusoidal waveform from the zero reference level, we can see this is the reference level. So below this value is Vm. As we can see here, this is Vm. So this will be also equal to Vm. And as we can see above this zero level, this was also Vm. So this value, this peak value, this is also equals to Vm. So we are getting a total value of 2 Vm in the negative direction. So the clamping is done in the negative direction. I hope we can all understand the working of this circuit. Thank you.